In this video, we're going to solve ground level concentration and maximum cavity concentration of a pollutant emitted from point source with building downwash in screen view. The problem is, consider an air pollutant emitting stack located on a simple flat terrain in a urban area. The point source has the following characteristics. Pollutant emission rate is 100 gram per second. Stack height 100 meter. Stack inside diameter is 2 meter. Stack gas exit velocity is 15 meter per second. Stack gas exit temperature is 450 Kelvin. Ambient air temperature is 293 Kelvin. Further, a structure with 80 meter height, 80 meter minimum dimension and 100 meter maximum dimension is present in the vicinity of the stack in question. Now, by using full meteorology, that is stability of all classes and wind speed are considered, determine the maximum ground level concentration across a range of automated distance from 100 meter to 1 kilometer and estimate the highest concentration value of pollutant as the maximum 1 hour cavity concentration of the source. Now this is my screen view, and I have already made project, so I'm going to open the projects and select the project .scr and enter the following characteristics and store type. And hit next. Terrain information, other terrain, simple terrain, flat terrain, automated distance, full meteorology. Keep non-regulatory options no, keep anemometer height 10 meter, then hit next. Complex terrain it is not, so it is as it is flat terrain, we need not to enter anything. And it is automated distance, we have to enter minimum distance 100 meter, maximum distance 1 kilometer. Discrete distance is not required. Downwash, building height, minimum and maximum horizontal distance is given, and no fumigation is not required. Then hit next. This window is appear, and you will find that at red it is written the project is complete. You can run it. After that, you will let run finish successfully. Hit the graph, and from the graph you can see that from the stack to at 800 meter maximum concentration is slightly more than 700 microgram per meter cube. So for details, hit output file here, and you can see this is the inputs information. Then you can find bouncy flux, momentum flux. Then you can find the all 10 array from 100 meter to with this concentration, and the maximum 1 hour concentration at or above 100 meter is 715.3 microgram per meter at 800 meter from the stack. And it is shown that the downwash is SS, and SS means is Saltzman square downwash used, and the two cavity calculation is there, cavity 1 and cavity 2. In cavity 1 the concentration is 3168 microgram per meter cube, and it is with the minimum horizontal dimension along with, and the second is the concentration is 1691 microgram per meter cube at maximum size. So in overall, the simple terrain concentration is this, and the building wash cavity for maximum concentration cavity 1 is here. So the answer of the first question is 715.3 microgram per meter cube at 800 meter from the stack, and the maximum building downwash concentration is 3168 microgram per meter cube at 142.41 meter. So building downwash means the downwash phenomenon caused by the aerodynamic turbulence induced by a building may result in high ground level concentration in the vicinity of an emission source. It is therefore important to characterize the height and width of structure of nearby source. For the purpose of this analysis, nearby includes structure within a distance of 5 times the lesser of the height or width of the structure, but not greater than 0.8 kilometer. So in this case, the maximum, the structure will be the from stack will be the 800 meter, and it is maximum. In this particular case, it is 80 meter is the height, minimum height. So 5 times of 80 meter, that is 400 meter. So within 400 meter, it is there. So nearby means this. And to avoid downwash problem, a simple thumb rule may be applied to determine the stack height. So if stack height is greater than or equal to, the building height plus 1.2 into the lesser of either building height or maximum projected building width. So it is here LB is 80. So 1.5, 80 is become 120, and HB is 100. So 220. If the stack height is greater than or equal to 220, then downwash problem may be, overlooked. So So if it is determined that the potential for ground wash exists, then screen view should be used to determine the maximum ground level concentration that occurs as a result of downwash. And when a screen view is run for building downwash calculation, two cavity calculation is made for using the minimum horizontal dimension along with, that is cavity 1 in our case, and the second using the maximum horizontal dimension along with, that is cavity 2. And the output provides the cavity concentration, cavity length, cavity height, and critical wind speed for each orientation, and the highest concentration value that potentially affects ambient air should be used as maximum 1 hour cavity concentration for the source. So for further and more information, you can go through the reference here.